Welcome to the Pocket Science channel. Hi everyone. We have already done the first two questions of the 2019 advanced level paper. If you have still not watched it, you can watch it from the link given below in the description. Today, let's see the next question of the paper. Before moving into the question, I want to give an explanation about how to represent the path of a variable complex number on an Argand diagram. The first is when the argument value is a constant. Now I am considering an example. Arg z minus z naught equal theta. And now let's see how to represent the path of the complex number z in an Argand diagram. I am drawing the real axis and the imaginary axis. You already know this is the real axis and this is the imaginary axis in an Argand diagram. Now I want to represent the path of the complex number z. Then I should first make it in this form z minus z naught, where z naught also a complex number. In here it is a fixed point. Then I am considering the z naught fixed point at a place like this. Okay, you can take example if it is as like this, z naught equal a plus ib, then a is the real part, b is the imaginary part, then this is the that point z naught. Then the argument value is a constant value, it is theta degrees. Then starting from this terminal line, I should mark a straight line path forming the angle theta degrees. Then this is the path of z complex number. Okay. Now the second is when the modulus value is a constant. Example, z minus z naught is a constant. Here the modulus value is constant. Similar way, I am drawing the Argand diagram. This is the real axis, this is the imaginary axis. In similar way, I am considering the example z naught equal a plus ib, then real part a, imaginary part b, this is the point z naught. Now in here the modulus value is a constant. In this type of question, the path of the complex number will be a path of a circle. In the above one, when the argument value is given, it is a straight line. When the modulus value is given, it will be a circle. Then by considering the constant value k as the radius, we can draw the circle. I am considering this much. This is the radius k. And this is the path of the complex number z. Okay. Now let's move into the question. The question is, sketch in an Argand diagram the locus of the points that represent the complex number z satisfying arg z minus 2 minus 2i equal minus 3 pi upon 4. Hence or otherwise find the minimum value of I z bar plus 1 modulus. such that arc is at minus 2 minus 2i equal minus 3 pi upon 4. And by using this, they are asking the minimum value of this modulus part. First, we should sketch the complex number z in the Argand diagram. Before that, we should make it in the form z minus z naught, what I have explained in the above part. R z, here it is z minus z2 minus 2y, and if I take minus out, I will get 2 plus 2i equal minus 3 pi upon 4. Now in here the fixed point is 2 plus 2i. Now I can sketch the path of z. This is the real axis, this is the imaginary axis. In here the fixed point is 2 plus 2y, then the real part is 2, then the imaginary number also 2, and this is the fixed point. Now the angle is minus 3 pi upon 4. From this terminal line, I should make an angle minus 3 pi upon 4. Since it is a negative angle, we should move in the clockwise direction. This value is equal to 135 degrees. If you consider in degrees, you know this is 90 degrees, then you should make another 45 degrees. You can see these two values are equal. Then if you join these 2 points, you can form the 45 degrees. It will be a isosceles right angle triangle. Then it will make 45 degrees. Then by joining these two lines, you can mark the path of the Z. Then okay. That is the first part of the question. Then the next part is hence or otherwise find the minimum value of modulus I z bar plus 1. Then we should change this into the form where having a complex number z in the modulus part. And let's see how to convert it. In this way, I am considering let z equal a plus ib. Then you know the conjugate z bar is equal to a minus I. Now it is given that the modulus of I z bar plus 1. You can write it as a minus ib plus 1, the modulus. And here ai is minus I squared b, I squared is minus 1, then it is equal to plus b plus 1. Then you know the modulus value is the square of real part and the imaginary part. We should add the value, the squares of real part and the imaginary part. Then we should take the square root of it. Then it will be like this. Now I am changing the real part as imaginary and the imaginary as real and rewriting the modulus as this. For both these complex numbers, the modulus value is same. Therefore, we can change and write it. Now I am having a plus ib plus I. Then a plus ib you are considered as Z. Then you can write it as Z plus I modulus. Now we can form this in the way Z minus Z naught as like this, Z minus I. Okay, now we have converted this modulus I Z bar plus 1 into Z minus times minus I modulus. Now I am going to represent that one in the same Argand diagram. The fixed point is minus I. That means in the imaginary axis it is equal to minus 1. Minus 1. Now we know already when the modulus is a constant, it will be a circle. Then in the question they are asking about the minimum value of that modulus. Then we should consider a circle, a path of a circle which having this point as center, and it should be a circle with minimum radius. Then by keeping this one as center and to intersect with this one, I can make a circle when the radius is the perpendicular line with the path of the above complex number. Then only we can get a circle with minimum radius. Then you know this will be the minimum value of that modulus. I have named this point as P and this as M. Hence, the minimum of modulus I Z bar plus 1 is equal to Pm. And if we found the value of Pm, it is the minimum value. Pm equals, then you know the angles. This angle is 135 degrees. Then this will be pi upon 4, 45 degrees. And this also equal to pi upon 4. You know this value is 1. Then Pm, you can take it as 1 sine pi upon 4. 1 times sine pi upon 4. Pi upon 4 is 1 upon root 2. Then the minimum value is 1 upon root 2. This is the way of representing a path of a complex number in an Argand diagram and finding the minimum or maximum value depending on the question. I think you have got an idea about doing this type of questions. If you need the explanation of other questions also, please keep our channel subscribed, and if you like this video, please put a like and share our video. Thank you.